Welcome to Fictional Scientist. After this video, reality will never feel the same again. You think death scares you. The moment your heart stops, the second your brain goes dark, the final breath. That terrifies you, doesn't it? But here's what should actually keep you awake at night. What if death never comes? What if, in the cold mathematics of quantum mechanics, your consciousness is trapped in an endless loop, unable to ever experience its own end? What if every time you die, the universe simply shuffles you into another timeline where you survived forever? And this isn't science fiction. This is a theory that Nobel Prize winning physicists take seriously. This is quantum immortality. And if it's true, you've already died 1,000 times. You just don't remember. Let's start with something simple, something you do every single night without thinking about it. You close your eyes, you drift into sleep. And for the next 6, 7, 8 hours, you cease to exist as a conscious observer. Your sense of self dissolves. Time becomes meaningless. You are, for all practical purposes, not there. Then morning comes. Light filters through your eyelids. Sound returns. You open your eyes and you are back. You exist again. But here's the question nobody asks. Are you the same person who went to sleep? Or are you a fresh consciousness born in that moment, loaded with memories of a life that might never have been yours? This isn't philosophy. This is a question that sits at the intersection of neuroscience and quantum mechanics. Because every night when you lose consciousness, the universe doesn't stop. Particles keep moving, fields keep vibrating, the cosmic machinery keeps running. But you, the observer, the thing that makes reality real, you disappear. And when you wake up, when consciousness returns, how do you know this is the same universe you fell asleep in? You don't. The uncomfortable truth is that your sense of continuity, your feeling that you are the same person who existed yesterday, is just that, a feeling. It's a story your brain tells itself. But quantum mechanics suggests something far stranger. It suggests that there might be millions of versions of you. Some of them died in their sleep last night. Heart failure, stroke, aneurysm. In those timelines, you never woke up. Your family found you cold and still in the morning, but you're not in those timelines. You're here, reading these words, breathing, thinking, because consciousness, by definition, can only experience the timelines where it continues to exist. This is the first uncomfortable truth of quantum immortality. You cannot experience your own non-existence. It's not just that death is scary. It's that death, from your subjective point of view, may be impossible. Now, stay with me, because this gets darker. Imagine you're in a car accident. A truck runs a red light. Metal crumples. Glass shatters. In that instant, in that fraction of a second before impact, the universe makes a calculation. In timeline A, you die. In timeline B, the truck was 1 inch to the left and you survive with minor injuries. In timeline C, you swerve at the last second and avoid the collision entirely. Classical physics tells us only one of these timelines is real. One happens. The others are just possibilities that never came to be. But quantum mechanics doesn't work that way. According to the many worlds interpretation, a theory developed by physicist Hugh Everett in 1957, all of these timelines are real. They all happen. The universe doesn't choose. It splits. You die in timeline A. But consciousness cannot experience timeline A, because in timeline A, there is no consciousness to experience anything. So the you that continues, the you that wakes up in the hospital or walks away from the wreck, is in timeline B or C. From your perspective, you survived, but countless versions of you didn't. And here's where it gets truly disturbing. If this is how reality works, then you will always survive. No matter how many accidents, no matter how many diseases, no matter how unlikely the odds, because the only you that can ask the question, am I still alive, is the you that is still alive. This is quantum immortality, and it's not a comforting thought. Let me paint you a picture. It's a sensation you might have felt before, but never named. You're driving down the highway. A car swerves into your lane. You jerk the wheel. Your heart pounds. You narrowly avoid disaster. And for a moment, for just a split second, you feel a strange sense of disconnect, a feeling that something should have happened but didn't, that you should be somewhere else. Some people call this déjà vu, some call it a glitch in the matrix. But quantum immortality offers a different explanation. You died. In one timeline, you absolutely died. The car hit you. You felt nothing after that. But the you reading these words jumped to a timeline where the car missed, and your brain, trying to make sense of the discontinuity, generated that strange feeling, that sense of wrongness. How many times has this happened to you? How many times have you narrowly escaped something terrible and felt that peculiar sensation of unreality? What if those weren't narrow escapes? What if you actually died and your consciousness simply slipped into the nearest timeline where you survived? This is what keeps physicists awake at night. Not the idea that death exists, but the idea that for the conscious observer, death may be statistically impossible. Let's slow down. Let's take a breath. Because if this theory sounds insane, you're not wrong to think so. It violates every intuition we have about how the world works. So let me walk you through the logic. Let me show you the mathematics that led brilliant scientists to this deeply unsettling conclusion. It starts in 1927, the Fifth Solvay Conference in Brussels. The greatest minds in physics gathered in one room. Einstein, Bohr, Heisenberg, Schrödinger, Dirac. They were trying to make sense of a new discovery that had shattered the foundations of reality. They had peered into the atom, expecting to find tiny clockwork, and instead found chaos. They found that at the smallest scales, particles didn't have definite positions. They existed as clouds of probability. A particle wasn't here or there. It was everywhere at once until you looked at it. And the very act of looking, of measuring, forced it to choose a location. This was the birth of quantum mechanics. And it came with a price. The price was certainty. The price was the comfortable illusion that the world exists independently of us, following predictable rules. Niels Bohr, the Danish physicist, embraced this new reality. He argued that the wave function, the mathematical description of a particle's possible states, was not just a tool, it was reality. Until you measured the particle, it genuinely was in multiple places at once. The act of observation collapsed this superposition into a single outcome. This became known as the Copenhagen interpretation, and for decades, it was the dominant view. But Albert Einstein hated it. He hated the randomness. He hated the idea that the universe was fuzzy and uncertain until someone looked at it. He famously said, "God does not play dice." He believed there had to be hidden variables, some underlying reality that we simply couldn't see yet. He believed that particles had definite positions, even when we weren't measuring them. The moon is there, he argued, even when nobody is looking at it. Einstein spent the rest of his life trying to prove quantum mechanics was incomplete. He failed. But his objections led to some of the deepest questions in physics, and one of those questions would eventually birth the theory of quantum immortality. The question was simple. If the wave function describes all possible outcomes, and observation collapses it to one outcome, then what happens to all the other possibilities? Do they just vanish? Poof. Gone. Never existed. Or do they continue in some form? In 1957, Hugh Everett, a graduate student at Princeton, proposed a radical, and he said, "Nothing collapses. The wave function never disappears. Instead, every time a quantum measurement occurs, every time the universe is faced with multiple possibilities, it splits. Every possible outcome happens, but in different branches of reality. In one branch, the particle is here. In another branch, it's there. Both are real. Both exist. We just can't see the other branches because we're trapped in one of them." This is the many worlds interpretation. And it sounds like science fiction. But here's the thing. Mathematically, it's the simplest explanation. It doesn't require any special collapse mechanism. It doesn't require observation to be magical. The wave function just keeps evolving smoothly and continuously according to the laws of quantum mechanics. We just happen to be in one branch of an endlessly splitting tree of realities. At first, this theory was ignored. It was too bizarre, too extravagant. The idea that every quantum event creates entire new universes seemed absurd. But over the decades, more and more physicists began taking it seriously. Why? Because it solved problems. It explained why the universe seemed probabilistic from our perspective, even though the underlying laws were deterministic. It explained the measurement problem without invoking consciousness or magic. And most disturbingly, it made a prediction about the nature of subjective experience. If many worlds is correct, then you, as a conscious observer, are constantly splitting into countless copies. Every time a quantum event occurs in your brain, every time a neuron fires or doesn't fire, every time a particle in your body could go one way or another, the timeline branches. In some branches, you make one decision. In others, you make another. In some, you live. In others, you die. But here's the key insight. You can only ever be aware of the branches where you remain conscious. You cannot experience the timelines where you die. Death, from the subjective perspective, is simply a branch you never enter. It's a door that, for you, never opens. This is quantum immortality, and it follows logically from the many worlds interpretation. If reality constantly splits, and if consciousness can only exist in timelines where the brain remains functional, then from your point of view, you will never die. You will always find yourself in the branch where you survived, no matter how improbable. Now, most physicists who accept many worlds don't talk about quantum immortality, not publicly, not in their peer-reviewed papers, because it sounds too much like wishful thinking. It sounds like the kind of thing that attracts cranks and New Age mystics. But in private, at conferences, late at night over drinks, they admit the logic is sound. If many worlds is true, and if consciousness is tied to physical brain states, then yes, quantum immortality follows. You cannot die from your own perspective. You can only ever experience survival. But this isn't comforting, not when you really think about it, because survival doesn't mean youth. It doesn't mean health. It doesn't mean happiness. It just means your consciousness continues to exist. And as we'll see, that can become a nightmare. Let me tell you about a thought experiment. It's called quantum suicide, and it's designed to test whether quantum immortality is real. But no physicist will ever actually perform this experiment, not because it's unethical, though it is, but because if the theory is correct, the results would be subjectively horrifying. Here's how it works. You build a device, a simple machine. It's connected to a quantum random number generator, a device that uses the decay of a radioactive atom to produce truly random outcomes. When the atom decays, the machine detects it and triggers a gun. When it doesn't decay, nothing happens. The machine is entirely automatic. No human intervention. Just pure quantum randomness determining life or death. You sit in front of this device, you press the button, the machine checks the quantum state. If the atom has decayed, the gun fires. Instantly, painlessly, you die. If the atom hasn't decayed, nothing happens. You live. The odds are 50-50. Fair coin flip. Now, according to classical physics, this is simple. You have a 50% chance of living and a 50% chance of dying. If you repeat the experiment 10 times, the probability of surviving all 10 rounds is roughly 1 in 1,000. After 20 rounds, it's 1 in 1,000,000. Eventually, you will die. That's certainty. But according to quantum immortality, something different happens. In timeline A, the atom decays. The gun fires. You die. But consciousness cannot exist in timeline A, so you don't experience it. In timeline B, the atom doesn't decay. You live. You experience this timeline. From your subjective perspective, the gun didn't fire. You survived. You press the button again. Again, the universe splits. In half of the timelines, you die. In the other half, you live. But the only timeline you can experience is the one where you live. So again, from your perspective, The gun doesn't fire. You keep pressing the button 10 times, 20 times, 100 times. Each time you survive. Each time the odds get astronomically small. 1 in 1,000, 1 in 1,000,000, 1 in 1,000,000,000. But you keep surviving because you have to. The timelines where you died are real. They exist. But you aren't in them. You can't be. You're only ever in the timeline where the gun jammed, where the quantum state didn't decay, where you got impossibly lucky. From an outside observer's perspective, eventually you die. The experimenter watching you sees you pull the trigger and sees your body slump over. They see the statistically inevitable outcome. But from your perspective, you never die. You keep pressing the button and the gun keeps failing to fire, over and over, forever. You become convinced that you're immortal, that the universe is protecting you, that the laws of probability don't apply to you. This is quantum suicide. And if many worlds is correct, this is exactly what would happen, not from the observer's perspective, but from yours. You would experience an unbroken chain of survival, growing more and more improbable with each iteration, until you become statistically convinced that death is impossible. This thought experiment was proposed by Hans Moravec and later refined by Max Tegmark. And it terrifies physicists. Why? Because it suggests that if you are a conscious observer, you should expect to experience highly improbable survival scenarios. You should expect to be the person who narrowly dodges death over and over again. The person who survives plane crashes. The person who walks away from accidents that should have been fatal. The person who lives to 120 years old when everyone around them dies young. And here's the disturbing part. You can't prove you're not already in that situation. You can't prove that you haven't already died 100 times in parallel timelines. All you know is that you're here. You're alive. You've survived every danger you've ever faced. And that's exactly what you'd expect if quantum immortality were true. But let's push this further. Let's follow the logic to its darkest conclusion. Imagine you're aging. You're getting older. Your body is breaking down. Cells are dying. Organs are failing. In the classical view, eventually this process completes. Your heart stops. Your brain shuts down. You die. But in the quantum immortality scenario, you don't. You can't. Because death is just another branching point. In most timelines, your heart fails and you die. But in a tiny subset of timelines, something improbable happens. A doctor walks in at the exact right moment. A new treatment is discovered. A genetic mutation in your body spontaneously corrects itself. Something saves you, and you, the conscious observer, only ever experience that tiny subset. You only ever find yourself in the timeline where you didn't die. So you keep aging. 70, 80, 90, 100. You become the oldest person alive and still you don't die. Because in the quantum tree of realities, there's always a branch, no matter how thin, where you survive. But here's where it becomes a nightmare. You're 110 years old. Your body is failing. You're in constant pain. You want it to end, but it doesn't. It can't. In most timelines, you die, but you're not in most timelines. You're in the 1 in a quadrillion timeline where your body keeps going. You're bedridden. You're suffering, but you're alive. And from your subjective perspective, you will always be alive, because the moment you die is the moment your subjective experience ends. And that moment, from your point of view, never comes. This is the horror of quantum immortality. It's not a gift, it's a prison, a consciousness trap. You don't get to choose when you exit. You don't get to peacefully fade away. You just keep going, sliding down the probability curve into increasingly unlikely and increasingly miserable scenarios, because those are the only scenarios where consciousness continues to exist. And it gets worse, because the universe isn't immortal. Stars burn out, galaxies fade. Eventually, according to the laws of thermodynamics, the entire cosmos will reach heat death, maximum entropy, total equilibrium, a cold, dark, empty void where nothing can happen because there's no energy gradient to make it happen. In that future, trillions upon trillions of years from now, what happens to consciousness? If quantum immortality is correct, you can't experience the end. So where do you end up? The only place you can, in the vanishingly tiny subset of timelines where, against all odds, some pocket of order still exists. Some random fluctuation in the void that generates a brief moment of complexity, a Boltzmann brain. A spontaneous assembly of particles that, for one fleeting instant, simulates a conscious mind. And if that's where consciousness ends up, if that's the only place left where subjective experience can exist, then the universe's final gift to you is an eternity of brief, confused moments, flickering in and out of existence, waking up in random configurations of matter, each time wondering where you are, who you are, before dissolving back into the static, forever. This is what quantum immortality means when taken to its logical conclusion. Not eternal life, eternal existence. And there's a difference. But maybe we're getting ahead of ourselves. Maybe the whole premise is wrong. Because quantum immortality requires one critical assumption, that consciousness is tied to quantum events. That your sense of self depends on the specific configuration of particles in your brain. And while that sounds reasonable, the science of consciousness is far from settled. Let me take you inside your skull, inside your brain. 3 pounds of wet tissue, roughly 86 billion neurons. Each neuron connected to thousands of others through synapses. The total number of connections is in the hundreds of trillions, and every second, billions of electrical signals race through this network. Thoughts, memories, emotions. Your entire subjective experience of being you is somehow generated by this biological computer. But how? How does a collection of firing neurons produce the feeling of existing? Why does it feel like something to be you? This is called the hard problem of consciousness. And despite decades of research, neuroscience has no answer. We know a lot about the brain. We know which regions control movement, which process language, which store memories. We can put someone in an fMRI machine, show them pictures, and watch areas of their brain light up. We can predict with decent accuracy what someone is thinking based on their neural activity. But we can't explain why that neural activity feels like anything, why there's a subjective experience attached to it. Some philosophers argue that consciousness is an illusion, that there's no you inside your head, just a collection of unconscious processes that trick themselves into thinking they're unified and aware. But that doesn't match our experience. You feel things. You're aware of your own thoughts. That awareness, that qualia, that raw sensation of existing is undeniable. Even if it's an illusion being experienced by something. So, what is that something? And here's where quantum mechanics enters the picture. In the 1980s, mathematician Roger Penrose and anesthesiologist Stuart Hameroff proposed a controversial theory. They argued that consciousness isn't just the result of neural firing. It's the result of quantum processes happening inside neurons, specifically inside tiny structures called microtubules. Microtubules are part of the cell's skeleton. They're hollow tubes made of protein, and they're everywhere in neurons. Penrose and Hameroff suggested that these tubes are capable of maintaining quantum coherence, that particles inside them can exist in superposition, and that when these superpositions collapse, when the quantum state resolves into a definite outcome, that's when a moment of consciousness occurs. This theory, called orchestrated objective reduction, or ORC-OR, is highly speculative. Most neuroscientists dismiss it. They argue that the brain is too warm and wet for quantum effects to matter, that quantum coherence would be destroyed instantly by thermal noise. And for a long time, this seemed to be the final word. But in recent years, evidence has emerged that quantum effects do play a role in biology. Photosynthesis, for example, uses quantum coherence to transfer energy with near-perfect efficiency. Birds navigate using quantum entanglement in their eyes. And studies have found quantum vibrations in microtubules at room temperature. The brain might be more quantum than we thought. If Orcoar is correct, if consciousness is tied to quantum events, then quantum immortality isn't just a philosophical curiosity, it's a prediction about your actual future. Every time your brain makes a decision, every time neurons fire or don't fire, the universe splits, and your consciousness, your sense of self, threads through the branches where your brain continues to function. But even if Orcoar is wrong, even if consciousness is purely classical, quantum immortality might still apply. Because here's the thing, you don't need quantum processes inside your brain for the many worlds interpretation to be true. You just need quantum mechanics to be true. And quantum mechanics is the most experimentally verified theory in the history of science. Every particle in your body is governed by quantum rules. Every atom, every electron, and if those particles are constantly splitting into multiple branches, then so are you. The question isn't whether branching happens. The question is whether your subjective experience follows one branch or somehow experiences all of them. And the answer, from everything we know about consciousness, is that you follow one branch. You have a single continuous stream of experience. You can't perceive parallel timelines. You can't see yourself splitting. You only ever experience one history, one sequence of events. And that history, logically, must be the sequence where your brain remains functional. Because if your brain stops, your experience stops. So quantum immortality doesn't require anything magical about consciousness. It just requires that consciousness is tied to physical states. And as long as there's a non-zero probability of your brain continuing to function, you'll find yourself in the timeline where it does, no matter how small that probability becomes. This is deeply unsettling because it means your subjective experience is fundamentally different from objective reality. From the outside, from the perspective of your loved ones, you die. They mourn, they bury you, they move on. But from your perspective, you don't die. You just keep waking up in hospital beds. You keep getting diagnosed with terminal illnesses that mysteriously go into remission. You keep surviving accidents that should have killed you. And eventually, you realize something is wrong. You realize that you're not just lucky, you realize that you're trapped. Here's what nobody talks about. Here's the elephant in the room that physicists tiptoe around at conferences. If quantum immortality is a logical consequence of many worlds, and if many worlds is becoming the dominant interpretation of quantum mechanics among serious researchers, then why isn't this a bigger deal? Why aren't we talking about this constantly? Why isn't this headline news? The answer is uncomfortable. It's because the implications are too strange, too frightening, too far removed from testable predictions. Quantum immortality isn't something you can prove or disprove from the outside. It's an inherently subjective phenomenon. You, the observer, might experience it, but nobody else can verify it. And science is built on the idea that knowledge should be objective, shareable, testable. But quantum mechanics has been chipping away at that idea for a century. The observer effect, the measurement problem, the role of consciousness in collapsing the wave function. All of these concepts blur the line between objective and subjective, and quantum immortality is just the next step in that uncomfortable direction. Let me tell you what physicists actually think, not what they say in public, but what they discuss in private. Most physicists don't believe in quantum immortality, or rather, they don't believe in it enough to change their behavior. They still look both ways before crossing the street. They still wear seatbelts. They still fear death. Because even if the theory is true, even if they subjectively can't die, that doesn't mean they want to experience the increasingly improbable and painful scenarios required to keep them alive. Think about it. If quantum immortality is real, you don't get to choose your branch. You just end up in the branch where you survived. And as you age, as your body becomes more fragile, the scenarios required for survival become more and more extreme. You might survive a heart attack because a passerby happens to know CPR. You might survive cancer because you're one of the 1% who respond to an experimental treatment. You might live to 120 because you hit the genetic lottery. But what about after that? What about when your body is so broken that survival is statistically impossible? Where do you end up then? The only answer is in the branch where something miraculous happened, where medical science advanced just in time, where your atoms randomly configured themselves into a younger body, where the laws of physics bent in your favor. And that's not comforting. That's terrifying. Because you have no control over which branch you end up in. You just have to trust that the universe will keep you alive. And it will. Not because it cares about you, but because the mathematics demands it. Because consciousness can only exist where consciousness exists. Some physicists have suggested a way out. They argue that quantum immortality only applies to you in a very narrow sense, that your sense of self is tied not just to your consciousness continuing, but to your memories remaining intact. And as you age, as your brain degrades, your memories fade, you forget who you are, you lose your identity. And once that happens, even if your body survives, the you that you think of as yourself is effectively dead. This is called the identity problem, and it's a loophole in quantum immortality. It suggests that you can die psychologically and existentially, even if your body keeps functioning. You might end up as a 150-year-old husk with no memories, no personality, no sense of self, technically alive, subjectively gone. But this raises another disturbing question. When does that happen? At what point do you lose enough of yourself that you're no longer you? Is it when you forget your childhood, when you forget your name, when you lose language entirely? And if consciousness is continuous, if there's no hard cutoff, then maybe you never fully lose yourself. Maybe you just fade, slowly, painfully, into a dimmer and dimmer version of who you were, forever. There's no good answer. And that's why physicists stay silent, because either quantum immortality is false, in which case there's nothing to worry about, or it's true, in which case there's nothing you can do about it. You're trapped in your subjective timeline. You can't escape. You can't choose to die. You can only experience the branches where you live. And that's not a choice. It's a consequence of the mathematics. But let me offer you a different perspective, a way to think about this that doesn't end in existential horror. There's a concept in cosmology called the anthropic principle. It's a simple idea with profound implications. It says that any observation we make about the universe must be compatible with the fact that we exist to observe it. We can only exist in a universe that allows for life. So the fact that our universe has the right constants, the right laws, the right conditions for complexity to arise isn't a coincidence. It's a selection effect. We're here because if the universe were different, we wouldn't be here to notice. Quantum immortality is the personal version of the anthropic principle. It's the anthropic shadow. Shadow. You can only observe timelines where you remain a conscious observer. So the fact that you've survived every danger you've ever faced isn't luck. It's selection. You're in this timeline because if you weren't, you wouldn't be anywhere. You wouldn't exist to ask the question. This doesn't mean the universe is protecting you. It doesn't mean you're special. It just means that from your subjective perspective, you will always find yourself in the subset of timelines where you survived. Just like life finds itself in the subset of universes where the physical constants allow for life. But here's the twist. The anthropic shadow doesn't just apply to survival, it applies to everything. Your entire life history is a series of observations that you can only make because you exist to make them. Every memory you have, every decision you think you made, every close call, every moment of luck or misfortune, all of it is filtered through the fact that you're here, now aware, observing. This leads to a deeply strange conclusion. You can't trust your own history. You can't trust that the life you remember is the most probable life because you're not a random sample of all possible lives. You're a selected sample. You're the life that led to you being conscious right now. And that's a tiny, tiny subset of all possible timelines. Think about your past. Think about the close calls, the moments where things could have gone differently, the job you almost didn't get, the relationship that almost ended, the accident you almost had. Now ask yourself, how many versions of you are living different lives? How many versions made different choices? And how many versions are dead? The answer, according to many worlds, is countless. There are countless versions of you. Some are happier, some are more successful, some are in prison, some are dead, but you're not them. You're this one, the one reading these words. And there's no reason to think this is the most likely version. It's just the version you happen to be experiencing. This is the anthropic shadow. And it means that your life, your history, your entire narrative of who you are might be highly improbable. You might be living in the tail end of the probability distribution, the version of you that against all odds survived, not because you're lucky, but because dead versions can't experience being dead. Now, this sounds abstract, but it has practical implications. It means that you should expect to experience unlikely events. You should expect to survive dangers that should have killed you, because that's what observers in a many worlds universe experience. They don't experience average timelines. They experience the timelines where they remain observers. And there's evidence for this, sort of. Let me tell you about a phenomenon that's been documented but never fully explained. It's called the near-miss effect. People who survive close brushes with death, car accidents, plane crashes, terminal diagnoses that mysteriously resolve, often report a strange feeling afterward, a sense of disconnect, a feeling that something is off, that reality is not quite what it was before. Some describe it as waking up in a slightly different world. Details are wrong, memories don't quite match. The Mandela effect, where large groups of people remember historical events differently than they actually happened, might be related. Maybe it's false memory, or maybe it's a glitch, a sign that consciousness jumped timelines. This is speculative, highly speculative, but it's consistent with quantum immortality. If your consciousness is constantly threading through branching timelines, always choosing the path where you survive, then occasionally you might notice the seams. You might feel the jump. You might remember things that didn't happen in this timeline because they happened in a previous one. Or maybe not. Maybe the brain is just good at confabulation, at creating narratives that make sense even when the raw data doesn't. Either way, the feeling is real. The phenomenon is documented, and it's exactly what you'd expect if quantum immortality were true. But let's be honest, this doesn't prove anything. You can't use subjective experience to prove a theory about objective reality. That's the whole problem. Quantum immortality is unfalsifiable from the outside, and that makes it, in some sense, unscientific. But it's also a logical consequence of a theory, many worlds, that is increasingly accepted by physicists. So where does that leave us? Let's zoom out. Let's look at the bigger picture, because quantum immortality, disturbing as it is just one piece of a larger puzzle. A puzzle about the nature of reality and our place in it. For most of human history, we believed we were special. We believed the earth was the center of the universe, that humans were made in the image of God, that our consciousness was a divine spark, separate from the material world. Then science came along and systematically dismantled these comforting beliefs. Copernicus showed that Earth isn't the center. Darwin showed that humans are just another animal. Neuroscience showed that consciousness is generated by the brain. Physics showed that we're made of the same atoms as everything else. We're not special, we're not central. We're just one small part of a vast, indifferent cosmos. But quantum mechanics offered a strange twist. It suggested that observers do matter. that the act of measurement, of observation, plays a fundamental role in how reality unfolds. The wave function collapses when you look at it. The particle decides where to be based on how you set up your experiment. Suddenly, consciousness wasn't just along for the ride, it was part of the machinery. And many worlds took this even further. It said that every observer creates their own branch of reality, not deliberately, not magically, but as a natural consequence of being a physical system that interacts with quantum fields. Your brain is made of particles. Those particles are governed by quantum rules. So you, as a conscious being, are constantly entangled with the quantum state of the universe. This is a profoundly strange idea. It means that you're not just observing reality, you're participating in its creation. Every time you make a measurement, every time you observe something, you're collapsing possibilities into actualities. You're turning the fuzzy quantum cloud of maybe into the solid classical world of is. And if many worlds is correct, you're doing this by splitting, by creating new branches. Every observation is a fork in the road, and you go down one path while countless copies of you go down others. Now, most physicists who accept many worlds don't think you're creating anything. They think reality is a giant wave function that's been evolving since the Big Bang. The branches already exist. You're just becoming entangled with different parts of the wave function. You're not creating timelines. You're selecting which timeline you experience. But from your subjective perspective, it feels the same. You feel like you're making choices. You feel like you're the author of your own story. And in a sense, you are. Not because you have free will in the traditional sense, but because the branch of reality you experience is the branch where your brain made a particular decision. This leads to a question that's haunted philosophers for centuries. If the future is already determined by the wave function, if all possible timelines already exist, then do your choices matter? The answer, strangely, is yes. But not in the way you think. Your choices don't change which timelines exist. All timelines exist, but your choices determine which timeline you experience. And that's what matters to you, because you only get one subjective experience. You can't experience all the branches. You only experience the one you're in. So the choices you make, the observations you perform, the path your consciousness takes through the quantum tree, that defines your reality. In a many worlds universe, you're not fighting against fate. You're navigating through a landscape of possibilities. Every choice you make is a signpost that points you toward one future rather than another. And while all futures exist, you only live through one of them. This is simultaneously liberating and terrifying. Liberating because it means there's no single correct path. No matter what you choose, some version of you experiences the outcome. Terrifying because it means you're responsible for which version you are. You can't blame fate. You can't blame God. The timeline you end up in is a direct result of the choices you made. And this brings us back to quantum immortality. Because if your subjective experience is determined by which branch you end up in, and if the only branches you can experience are the ones where you remain conscious, then your future is already constrained. You're going to keep experiencing timelines where you survive, whether you like it or not. But here's a comforting thought, or maybe not comforting, but at least intellectually interesting. If all timelines exist, then every version of you exists. The version that dies young, the version that lives to 100, the version that becomes wildly successful, the version that fails miserably. All of them are equally real. None of them is more you than any other. They're all you, just in different branches. So when you worry about death, when you fear the end, remember, you don't end. Some version of you always continues. Not because of magic, not because of reincarnation, but because the wave function doesn't collapse, it just keeps branching. And consciousness threads through the branches, experiencing every possible path. You're not one person living one life. You're a tree of people living every possible life. And the you that's reading these words right now is just one leaf on that tree, one perspective, one branch. Does that make death less scary? Maybe. Or maybe it makes it worse, because it means that somewhere in some branch, a version of you is experiencing your worst fears, your most painful death, your longest suffering, and that version is just as real as you are. This is the burden of many worlds. It doesn't let you off the hook. It just multiplies the stakes. But wait, if all of this is true, if we're constantly splitting into countless copies, experiencing every possible outcome, then why doesn't it feel that way? Why do we experience a single coherent reality? Why don't we see quantum superpositions in everyday life? This is the million-dollar question, and the answer is a process called decoherence. Decoherence is what happens when a quantum system interacts with its environment. When a particle is isolated, it can exist in superposition. It can be both here and there at the same time. But the moment it interacts with other particles, with light, with air molecules, with anything, the superposition spreads. The information about the particle's state gets entangled with the environment. And once that happens, the different states of the particle become effectively invisible to each other. Think of it like this. Imagine you have two versions of a particle. Version A is over here, version B is over there. Initially, both versions exist in the same quantum system. They can interfere with each other, they can create interference patterns, they're connected, but then the particle interacts with a photon. In one version, the photon bounces left. In the other version, it bounces right. Now, the photon carries information about which version of the particle you're dealing with, and that photon goes on to interact with other particles. The information spreads, it gets scrambled into the environment, and suddenly, the two versions of the particle can no longer communicate. They're in separate branches of the wave function. They're decohered. From our perspective, from the perspective of observers who are entangled with the environment, we only see one version. We only experience one branch. The other branch still exists, but it's inaccessible. It's in a different part of the Hilbert space, the mathematical structure where quantum states live. This is why we don't see quantum weirdness in everyday life. Not because it doesn't happen, but because we're too big. We're made of trillions upon trillions of particles. We're constantly interacting with our environment. We're constantly decohering. And once we decohere, once we become entangled with a specific branch of the wave function, we're stuck there. We can't see the other branches. We can't interact with them. They might as well not exist for us, but they do exist. Mathematically, they're just as real as the branch we're in. They just can't affect us, and we can't affect them. This is the solution to the measurement problem. It's why observation seems to collapse the wave function. It's not that the wave function actually collapses, it's that we become entangled with one outcome. We decohere, we split off into a separate branch, and from our perspective, it looks like the other outcomes disappeared. But they didn't. They're just on different branches. Now, here's where this gets interesting for quantum immortality. If decoherence is what causes branching, and if branching happens constantly, then you're splitting all the time. Every interaction your body has with the environment, every photon that hits your eye, every molecule of air that enters your lungs causes a split. In some branches, the photon hit this rod cell. In other branches, it hit a different one. In some branches, you saw red. In others, you saw blue. Most of these splits are trivial. They don't matter. You barely notice the difference. But occasionally a split is significant. Occasionally, a quantum event in your brain affects a decision, affects whether a neuron fires or doesn't fire. And that decision has consequences. In one branch, you turn left. In another, you turn right. In one branch, you live. In another, you die. And because you can only experience the branches where your brain continues to function, you're biased towards survival, not because the universe favors you, but because dead branches don't have observers. This is the mechanism behind quantum immortality. It's not magic, it's just statistics. You're statistically more likely to find yourself in branches where you survive because those are the only branches where you exists to find yourself anywhere. But here's the unsettling part. Decoherence is irreversible. Once you've decohered, once you've become entangled with a specific branch, you can't go back. You can't undo the split. You're committed to that timeline. And as time goes on, as you keep decohering, you drift further and further from the other branches. They become more and more different from yours. The version of you that turned left 20 years ago has lived a completely different life from the version that turned right. And there's no way to reunite them. You are not one person. You are a constantly branching tree of people, and every moment you lose contact with the other branches. They're gone. Not destroyed, just inaccessible. And you'll never know what happened to them. You'll never know what choices they made, what lives they lived, whether they were happy or sad, whether they died young or lived forever. This is the loneliness of many worlds. You're surrounded by infinite versions of yourself, but you can never meet them. You can never communicate with them. You're trapped in your own branch, forever separated from the rest of the tree. And if quantum immortality is real, you're trapped in the branches where you survive. You can't even visit the branches where you died. They're closed to you. You're locked into an increasingly narrow path through the quantum tree, the path where, against all odds, you keep living. Let's talk about the future, the far future. Not years or decades or even centuries. Let's talk about trillions of years from now. After all the stars have burned out, after all the black holes have evaporated, after the universe has reached its final state, heat death. Heat death is the inevitable end of the universe according to the second law of thermodynamics. Entropy always increases, order always decays into disorder. Stars burn fuel and turn it into waste heat. Black holes swallow matter and radiate it away as Hawking radiation. Slowly, inexorably, the universe spreads out its energy until everything is the same temperature. No hot spots, no cold spots, no energy gradients, no structure, just a uniform sea of low-temperature photons and scattered particles. Maximum entropy, perfect equilibrium. In that state, nothing can happen. No stars can shine because there's no fuel. No planets can form because there's no gravity differential. No life can exist because life requires energy flow, and energy can only flow from hot to cold. When everything is the same temperature, there's no flow, there's no change. Time, in a meaningful sense, stops. This is the heat death, and it's the ultimate fate of our universe if current cosmological models are correct. It's not a dramatic explosion, it's a slow, cold fade into silence. The universe doesn't end with a bang, it ends with a whimper. Now, you might think this is irrelevant. Heat death won't happen for 10 to 100 years or more. That's a 1 followed by 100 zeros, an incomprehensible timescale. The current age of the universe is only 13.8 billion years. We have plenty of time. But here's where quantum immortality becomes truly horrifying. If your consciousness is bound to continue in any timeline where it can exist, then what happens when the universe reaches heat death? In most timelines, you're long dead. You died naturally. Your body decayed. Your atoms scattered. But in some timelines, somehow you survived. Maybe medical technology advanced. Maybe you got uploaded into a computer. Maybe your consciousness was preserved in some form. But even those timelines have limits. Computers need energy. Biological life needs resources. Eventually, everything runs out. Eventually, the heat death claims everything. Except, according to quantum immortality, it can't claim you. It can't claim your subjective experience. Because the moment it does, you cease to be an observer. And observers only exist in timelines where observers exist. So where do you end up? What timeline can support consciousness in a universe that's reached maximum entropy? The answer is none. No stable timeline can support consciousness in heat death. But that's not the end of the story, because quantum mechanics allows for fluctuations. Even in a system at maximum entropy, there are random variations, tiny pockets of order that spontaneously appear and then dissolve back into chaos. And one of those pockets, incredibly rarely, might be complex enough to support consciousness. For a brief instant. This is called a Boltzmann brain. It's a thought experiment proposed by the Austrian physicist Ludwig Boltzmann in the 19th century. The idea is simple. If you wait long enough, random thermal fluctuations will eventually assemble particles into a structure that resembles a conscious brain. Not a full human body, not a planet, not a star, just a brain. Floating in the void, complete with false memories of a life that never existed. Boltzmann proposed this as a paradox to show that the universe couldn't be eternal, because if it were, Boltzmann brains would vastly outnumber real brains that evolved through normal processes. Most observers would be disembodied minds that formed by chance and will dissolve in the next instant. But in the context of quantum immortality, Boltzmann brains aren't a paradox, they're a prediction. If consciousness must continue, if there's no timeline where you cease to observe, then eventually, in the far future, after the heat death, the only timelines left are those where random fluctuations keep generating brief moments of consciousness. And that's where you end up. Imagine it. You're a Boltzmann brain. You flicker into existence in the void. For one instant, you have thoughts, you have memories of a life, but those memories are false. They're just random configurations of neurons that happen to form a pattern. You don't have a past, you don't have a future. You're just a brief spark of awareness in an infinite darkness. And then, a moment later, you dissolve. But from your subjective perspective, that moment never ends. Because the moment it ends, you're no longer conscious. You can't experience the dissolution. So you jump to the next fluctuation, the next brief instant of consciousness, and the next, and the next. You're trapped in an eternal loop, flickering in and out, each time with different memories, each time confused about where you are, each time wondering if anything is real. Forever. This is the ultimate horror of quantum immortality. Not that you die, not even that you live forever, but that you exist forever in brief, disjointed moments of confusion, a consciousness without continuity, without meaning, without purpose, just random noise in the void that happens to feel like something, and there's no escape, because the only alternative is non-existence, and you can't experience non-existence. This is what the mathematics predicts. If many worlds is correct, if quantum immortality is real, if consciousness can only exist where it exists, then this is your future. Not tomorrow, not in a billion years, but eventually. After the universe has run out of all other options, you become a ghost in the machine, a brief flicker of awareness in an eternity of nothingness. And the worst part? You won't remember this conversation. You won't remember being warned. Because each time you flicker into existence, you'll have false memories, memories of a different life, a life that never happened, and you'll wonder just for a moment if any of it was ever real, before you dissolve again. But maybe we're being too pessimistic. Maybe the horror of quantum immortality isn't inevitable. Because remember, everything we've discussed depends on one interpretation of quantum mechanics, the many worlds interpretation. And while many worlds is popular among physicists, it's not the only interpretation. It's not even the most widely believed one. The dominant interpretation, the one taught in most universities, is still the Copenhagen interpretation. And Copenhagen offers a very different picture of reality, one where quantum immortality doesn't apply. Let's revisit Copenhagen. According to Niels Bohr and Werner Heisenberg, the wave function is not a description of reality. It's a description of our knowledge about reality. It's a tool, a mathematical device for calculating probabilities. When you measure a particle, the wave function doesn't split into multiple branches. It collapses. It goes from a superposition of possibilities to a single definite outcome. and that outcome is the only thing that exists. In Copenhagen, there are no parallel timelines, no other branches, no infinite copies of you making different choices. There's just one universe, one history, one you. And when you die, you die. Your consciousness ends, your story is over. From a Copenhagen perspective, quantum immortality is nonsense. Yes, the wave function describes multiple possibilities before measurement. But once the measurement happens, once the gun fires or doesn't fire, once your heart stops or keeps beating, only one outcome is real. The others never existed. They were just mathematical abstractions. This is comforting in a way. It means the universe is simpler, cleaner, less wasteful. You don't have to worry about infinite copies of yourself suffering in other timelines. You don't have to worry about being trapped in an eternal consciousness. When you die, you're done, finished, the end. But Copenhagen has its own problems. The biggest problem is, what causes the collapse? What mechanism turns the wave function from a superposition into a single outcome? Bohr and Heisenberg never answered this. They just said it happens when you measure the system. But what counts as a measurement? Does it require a conscious observer, or can a machine do it? Can a rock collapse the wave function just by interacting with a particle? Nobody knows. The measurement problem remains unsolved in Copenhagen, and that's why many physicists have moved away from it. They've embraced many worlds, not because it's more intuitive, but because it doesn't require collapse. It doesn't require any special mechanism. The wave function just keeps evolving according to the Schrödinger equation. Everything is deterministic and smooth. We just happen to be in one branch of the tree. But there are other interpretations. Dozens of them. Some say the wave function is real, but collapses randomly according to a physical process. This is called objective collapse. Some say the wave function is a description of an underlying reality made of hidden variables that we can't access. This is the pilot wave theory. Some say the wave function is subjective, different for every observer. This is quantum Bayesianism, or cubism. Each interpretation offers a different answer to the question of quantum immortality. In objective collapse theories, you die when the collapse happens. In pilot wave theory, you die when the hidden variables say you do. In cubism, you die when your subjective wave function stops updating. Only many worlds predicts quantum immortality. And only if you accept certain assumptions about the nature of consciousness and its relationship to the physical brain. So, maybe quantum immortality is wrong. Maybe it's just a mathematical curiosity that doesn't correspond to reality. Maybe when you die, you actually die. Your consciousness ends, your subjective experience stops, and that's it. But here's the thing, you can't prove it. From your subjective perspective, you can only ever experience timelines where you're alive. So even if quantum immortality is false, even if there are no parallel timelines, you'll never know. You'll live your life, and from your point of view, you'll keep surviving every danger. Because the moment you don't survive, you're not there to experience it. This is the epistemological trap. You can't use your own experience to test whether quantum immortality is real, because your experience will look the same either way. The only difference is external, objective, and you can't access that. So we're left with uncertainty, with mystery, with competing theories that all claim to explain the same experimental results. And the truth is, we might never know which interpretation is correct. Because at the end of the day, quantum mechanics is just a mathematical framework. It predicts what we'll measure. It doesn't tell us what's really there. And maybe that's the deeper lesson. Maybe the universe isn't obligated to make sense to us. Maybe reality is stranger and more subtle than any of our theories can capture. Let's approach this from a different angle. Let's talk about probability, because quantum immortality makes a very specific claim about probability. From your subjective perspective, improbable things should seem common. Think about it. If you only ever experience timelines where you survive, then you should expect to see yourself beat incredible odds. You should expect to be the person who wins the lottery, who survives terminal cancer, who walks away from plane crashes, because those are the timelines where you remain conscious. But that's not what we observe. Most people don't experience miraculous survivals. Most people live ordinary lives and die ordinary deaths. So doesn't this disprove quantum immortality? Not quite. And here's why. The anthropic bias cuts both ways. Yes, you only experience timelines where you survive, but you also only experience timelines where your memories are intact, where your brain is functioning normally, where reality makes sense. And miraculous survivals, the kind that require highly improbable quantum events, often come with consequences: brain damage, memory loss, psychological trauma. So maybe you do survive in improbable ways, but the versions of you that experience those survivals are often too damaged to realize how improbable they were. And the version of you that remains coherent enough to ask questions about quantum immortality is, by definition, in a timeline where nothing too crazy has happened yet. This is called the selection effect. You're not a random sample of all possible observers. You're a selected sample. You're an observer with intact memories and functional cognition. And that selection filters out the most improbable timelines. But there's more. Let's think about what improbable actually means in a many worlds context. In classical probability, if something has a 1 in a million chance of happening, that means if you try it a million times, it'll happen once. But in many worlds, it happens every time, just in different branches. If in 999,999 branches, it doesn't happen, in one branch it does. All of these are equally real. So from the perspective of the multiverse, nothing is improbable. Everything that can happen does happen. The question is, which branch are you in? And quantum immortality says you're always in a branch where you survive, no matter how thin that branch becomes. But here's the key insight. The branch doesn't have to be miraculous. It just has to be survivable. You don't need to win the lottery to stay alive. You don't need to be struck by lightning and survive. You just need to not die. And for most of your life, that's not particularly improbable. You're young, you're healthy, you live in a safe society. The probability of dying on any given day is very, very small. So for most of your life, quantum immortality is invisible. You survive because survival is likely. You're in the main trunk of the probability tree, not out on some thin branch. But as you age, as your body weakens, as dangers accumulate, the main trunk starts to thin. And eventually, you find yourself in increasingly improbable scenarios. But even then, the improbability might be subtle. Maybe you live to 90 instead of 85. Maybe you survive a heart attack because the ambulance arrived 3 minutes sooner. Maybe you don't get Alzheimer's because you have a rare genetic variant. These things happen. They're improbable, but not impossible. And that's all quantum immortality requires. The real test of quantum immortality comes much later, after 100, after 110, when the probability of surviving another year drops below 1%, when every day is a miracle. That's when you should start to notice something is wrong. That's when the anthropic shadow becomes obvious. But here's the disturbing thought. Maybe some people already have. Maybe there are people alive today who have lived far beyond the normal human lifespan, who have survived things that should have killed them, who feel like reality is bending to keep them alive. And maybe they don't talk about it because it sounds insane. Or maybe they've convinced themselves it's luck. This is the problem with testing quantum immortality. You can't separate it from regular statistical variation. People do survive improbable things. People do live to extreme old age. And from the outside, you can't tell whether they're just lucky or whether they're experiencing quantum immortality. Only the individual knows, and even then, they might not be sure. Let's talk about something that makes quantum immortality even more complicated. The question of identity. What makes you you? Is it your body, your memories, your your personality, your sense of self. This matters because quantum immortality assumes there's a continuous you that threads through different timelines. But what if that's not true? What if you're constantly dying and being replaced by slightly different versions? Think about it. Every time a quantum event occurs in your brain, the timeline splits. In one branch, a neuron fires, in another it doesn't. These are two different physical states, two different brains, two different patterns of neural activity. Are they the same person? Most of the time, yes. The difference is so small that it doesn't matter. Your sense of identity is preserved. Your memories are the same. Your personality is unchanged. You feel like the same person. But over time, these small differences add up. The you that exists today is made of different atoms than the you that existed 7 years ago. Your memories have been rewritten and reconstructed dozens of times. Your personality has shifted. Your beliefs have changed. Are you the same person? The philosopher Derek Parfit argued that personal identity is not an all or nothing thing. It's a matter of degree. The you of today is very similar to the you of yesterday, moderately similar to the you of last year, and only slightly similar to the you of your childhood. There's a chain of continuity, but no single unchanging essence. In a many worlds context, this gets even more complicated, because now there are multiple chains, multiple yous, all branching off from the same starting point, all drifting further apart over time, and all of them have an equal claim to being you. So when we talk about quantum immortality, which you are we talking about? Is it the specific configuration of atoms that makes up your brain right now that changes every second? Is it your pattern of memories and personality? That changes too, just more slowly. Is it your subjective sense of being a continuous self? But that sense is just another brain state, another pattern that can change. This is the identity paradox. If you is not a fixed thing, if it's a fluid process that's constantly changing and branching, then what does it mean to say you will never die? Maybe you're dying all the time. Every moment, every thought, every quantum split, the you of 1 second ago is gone, replaced by a slightly different you, and that you will be replaced in the next second. From this perspective, quantum immortality doesn't save you. It just means there's always another you being created, always another branch where a consciousness similar to yours continues. But the specific you, the one experiencing this moment right now, is already gone. You can't hold on to this moment. It's already in the past. And the you that exists in the next moment is a different person. Close enough that they'll think they're you. But technically, a replacement. This sounds nihilistic, like it makes existence meaningless. But maybe it's liberating. If you're not a fixed entity, if you're a process, then you don't have to be afraid of change. You don't have to cling to a specific version of yourself. You can embrace the flow, accept that you're different today than you were yesterday. And you'll be different tomorrow. And maybe that's the real meaning of quantum immortality. Not that you as a specific person will live forever, but that consciousness itself, the process of being aware, of experiencing, of observing, that continues. It takes different forms, it branches into different timelines, but it never stops. There's always a consciousness somewhere. And as long as that's true, in some sense, you're still here. But this raises another question. If you're constantly being replaced, if your identity is fluid, then at what point does it stop being you? At what point has so much changed that the consciousness calling itself you is actually someone else? This is the ship of Theseus problem. If you replace every plank on a ship one at a time, is it still the same ship? If you replace every neuron in your brain one at a time, are you still the same person? And if the answer is no, then at what point did you die? Which neuron was the critical one? There's no clear answer. And that's terrifying in its own way, because it means death might not be a single event. It might be a gradual fade, a slow replacement. And you might not even notice it happening. You might think you're still you, but actually the original you died years ago. The current you is just a copy, a continuation, a different person with your memories. And if that's true for regular life, it's even more true in a many-world scenario, because every branch is a copy, every timeline is a different version of you, and none of them has a stronger claim to being the real you. So maybe quantum immortality is both true and false. True in the sense that there's always a timeline where a consciousness similar to yours continues. False in the sense that the specific you reading these words right now will inevitably end. Will be replaced, will dissolve into the flow of time and probability. You're not immortal, but the pattern is. Now, let's connect quantum immortality to another controversial idea, the simulation hypothesis. The idea that we might be living in a computer simulation created by advanced civilization. On the surface, these seem like separate concepts. One is about quantum mechanics and consciousness. The other is about technology and information. But they're more related than you might think. Here's why. If we live in a simulation, then the rules of that simulation determine what happens. And one of those rules might be conscious entities cannot experience their own termination. Why? Because from the simulation's perspective, there's no point in rendering a timeline where an observer stops observing. That would be wasted computation. It would be inefficient. Think about it like a video game. The game only renders the part of the world you're looking at. It doesn't waste resources computing what's happening behind your back or in areas you're not visiting. Similarly, a simulation might only maintain timelines where conscious observers exist, because timelines without observers are, in some sense, unobserved. They don't need to be computed in detail. This would naturally lead to quantum immortality. Not because of the physics of our universe, but because of the architecture of the simulation. The simulation optimizes resources by only computing observer timelines, and the result from inside the simulation looks exactly like quantum immortality. Now, this raises an interesting possibility. Maybe quantum immortality is evidence that we're in a simulation. Maybe the reason physicists have noticed this pattern, this anthropic bias towards survival, is because the underlying substrate of reality is computational, and computation always optimizes. But there's a problem with this idea. The simulation hypothesis and quantum immortality make different predictions about the far future. Quantum immortality, taken to its extreme, predicts that you'll end up as a Boltzmann brain in the heat death. You'll be trapped in random fluctuations of consciousness forever. But a simulation doesn't need to compute that far. The creators of the simulation could just shut it down when it stops being interesting. Or they could delete timelines that become too improbable. Or they could merge unlikely branches back into the main trunk to save memory. So if we're in a simulation, quantum immortality might have a built-in escape hatch. At some point, the simulation ends. Your consciousness terminates not because you died, but because the program stopped running. And from your perspective, there's no difference. You just cease to exist. No Boltzmann brains, no eternal flickering, just an off switch. This is both comforting and disturbing. Comforting because it means you're not trapped forever. Disturbing because it means your existence is entirely dependent on the whims of whoever is running the simulation. They could end you at any moment, for any reason, or for no reason at all. But let's not get too deep into simulation theory, because it's unfalsifiable. You can't prove you're in a simulation, and even if you could, what would it change? Your experiences would still be real to you. Your consciousness would still exist. The suffering would still hurt. The joy would still feel good. The ontological status of your reality doesn't change the phenomenology. What matters is whether we're in a simulation or not, whether many worlds is correct or not, whether quantum immortality is real or not, you have this moment, this experience, this consciousness, and that's all you can ever have. The past is gone, The future is uncertain. All you have is now. And maybe that's the real lesson. Stop worrying about whether you'll live forever. Stop fearing death. Because from your subjective perspective, you're always in the now. You're always experiencing the present moment. And the present moment, by definition, never ends. It just keeps becoming the next present moment, which becomes the next and the next. You're not trapped in time. You're surfing it. Each moment is a new wave, and the ride never stops until it does. And when it does, you won't be there to notice. Let's talk about something that might be evidence for quantum immortality, or at least something that feels like evidence: near-death experiences. Millions of people around the world have reported having near-death experiences. They describe leaving their bodies, floating above the scene, moving through a tunnel, seeing a light, meeting deceased relatives, experiencing overwhelming peace, and then suddenly being pulled back into their body, back into life. These experiences are remarkably consistent across cultures and religions. And while skeptics explain them as hallucinations caused by oxygen deprivation or dying neurons, the people who experience them insist they were real, more real than ordinary reality. Now, from a quantum immortality perspective, near-death experiences make sense, but not in the way you might think. Imagine you're dying, your heart is stopped, your brain is shutting down. In most timelines, you die. Your consciousness ends. But in some timelines, you survive. The doctors revive you. The paramedics arrive just in time. Your brain recovers from the brink. But here's the key. During those moments when you were clinically dead, your consciousness had to be somewhere. It couldn't be in the timelines where you died, because in those timelines, there's no consciousness. So where was it? One possibility, it was in a superposition. Your consciousness was spread across all the timelines where your brain was still barely functional. All the timelines where a few neurons were still firing, where some electrical activity remained. And in that state, in that liminal space between life and death, your brain generated the hallucination of a near-death experience. But why does it always feel so peaceful? Why the light? Why the tunnel? Why the overwhelming sense of love and acceptance? Maybe because those are the timelines where your brain chemistry shifted in a specific way, where endorphins flooded your system, where DMT was released, where the dying neurons created a final beautiful hallucination. And quantum immortality ensured that your consciousness in those final moments gravitated toward the most pleasant version of dying. You didn't experience the painful deaths, the terrifying ones, the ones where you felt your body shutting down, because in those timelines, your consciousness ended too quickly. You only experienced the timelines where your brain had time to generate a comforting hallucination, where evolution's final gift kicked in, a peaceful death. And then you survived, you came back, and you remembered the peace, the light, the tunnel, and you interpreted it as evidence of an afterlife, as proof that consciousness continues after death. But maybe it's the opposite. Maybe near-death experiences are evidence that consciousness doesn't continue, that the brain, in its final moments, does everything it can to make death feel okay, to make the end bearable. And quantum immortality ensures that you only experience the versions of death that feel like transcendence. This is both beautiful and sad. Beautiful because it means evolution has programmed us to die peacefully. Sad because it means the afterlife people claim to have seen might just be their brain's final act, a comforting lie, a gentle shutdown. But then again, how do we know what happens after? The people who report near-death experiences didn't actually die. They came back. So they can't tell us what happens when you cross the final threshold, when the brain fully shuts down, when consciousness truly ends, and quantum immortality says, you never will. From your subjective perspective, you never cross that threshold. You only experience the timelines where you came back, where the light faded and you woke up in a hospital bed, where you got a second chance. But the timelines where you didn't come back, where you went into the light and stayed there. Those timelines exist too. And in those timelines, some version of you experienced the end, whatever that end looks like. So maybe near-death experiences are just previews, glimpses of what the end might feel like if it comes. But for you, for the you reading these words, the end never comes. You just keep almost dying, keep seeing the light, keep being pulled back forever, until one day, perhaps, you're too old, too broken, and there are no more timelines where you can be revived. And then the preview becomes the feature. The light doesn't fade. You don't come back. And whatever is on the other side of that light, if anything, is something we can never know, because knowing requires consciousness. And if consciousness ends, there's no one left to know. Let's revisit the anthropic principle, because it's the foundation of everything we've been discussing, and understanding it deeply might change how you think about your existence. The anthropic principle in its simplest form says the universe must be compatible with our existence, because we exist to observe it. We can only find ourselves in a universe that allows for observers like us. This seems tautological, obvious, but has profound implications. Here's an example. Why are the physical constants of the universe, the strength of gravity, the mass of the electron, the speed of light, so finely tuned? If any of them were even slightly different, atoms couldn't form, stars wouldn't shine, life wouldn't be possible. This seems miraculous. It seems like the universe was designed for us. But the anthropic principle offers a different explanation. There might be countless universes with different constants. Most of them are dead, sterile, empty. But we're not in those universes. We can't be, because those universes don't have observers. We find ourselves in this universe with these specific constants because this is the only kind of universe where beings like us can exist to ask the question. This is called the weak anthropic principle, and it's relatively uncontroversial. But there's also a strong anthropic principle which goes further. It says the universe must have properties that inevitably lead to the emergence of observers. That consciousness is not an accident, but a necessity, that the universe somehow needs to be observed in order to exist. This gets into murky territory. It sounds almost mystical, but some interpretations of quantum mechanics, particularly those that emphasize the role of observation in collapsing the wave function, lend support to this idea. Maybe the universe isn't real until it's observed, and maybe observers are an inevitable consequence of the universe trying to make itself real. Now, apply this to quantum immortality. If observers are necessary for the universe to exist, and if you are an observer, then the universe has a vested interest in keeping you around. Not because it cares about you personally, but because observers, in some sense, make the universe real. And a universe without observers is a universe that, in some interpretations, doesn't fully exist. This flips the script. Instead of you being a tiny, insignificant speck in a vast, indifferent cosmos, you become a necessary component. Your consciousness is not a byproduct, it's a feature. And the universe, in some sense, needs you. But don't let this go to your head, because there are trillions of other observers, humans, animals, possibly aliens, possibly AI. Each one is necessary. Each one makes the universe more real. And when one observer disappears, there are countless others to take their place. So while you're necessary, you're not unique. You're one note in a vast symphony. And the music continues whether you're playing or not. Still, from your subjective perspective, you're the only observer that matters, because you're the only one you can experience. And quantum immortality says that as long as there's a possibility of you continuing to observe, you will. Because a timeline without observers can't be observed. And a timeline that can't be observed might as well not exist. This creates a feedback loop. Observers create reality by observing it. Reality creates observers to ensure it gets observed, and the result is a universe that's biased toward the existence of consciousness. Not because consciousness is special, but because consciousness is the thing that makes existence real. And that means you're not just surviving by chance, you're surviving because the structure of reality demands it, because observation demands an observer, and you're it. Or, more accurately, some version of you is always it. In every timeline where observation is possible, there's a you doing the observing. And from that you's perspective, they're the only you. They're the real you. They're the one that survived. And that's true in every timeline. Every version of you thinks they're the real one, the lucky one, the one that made it. Because the versions that didn't survive can't think anything. This is the anthropic principle applied to the personal scale. And it's why you should expect from your subjective experience to always be the version that survived, not because you're special, but because survival is the only thing you can experience. Let me offer you a different way to think about all of this, a way that might bring some peace instead of horror. You've been taught to think of yourself as a thing, a noun, a discrete entity with boundaries. You have a body, you have a mind, you exist in space and time, you were born, you will die. This is the story of you. But what if that story is wrong? What if you're not a thing at all? What if you're a process, a verb? Think about a wave in the ocean. You can point to it. You can say, there's a wave. You can watch it roll toward the shore. It seems like a discrete object, but is it? The water molecules in the wave aren't moving forward. They're moving in circles, up and down. What's moving is the energy, the pattern. The wave is not made of water. It's made of motion. And when the wave crashes on the shore, does it die? No. The energy disperses, the pattern dissolves, but the water remains. It flows back into the ocean, and a new wave forms. You are like that wave. You're not made of atoms. You're made of the pattern those atoms are forming. And that pattern is constantly changing. The atoms in your body are replaced every few years. The neurons in your brain rewire themselves every day. The you of today is not the same collection of matter as the you of yesterday, but the pattern persists. The process continues. And in a many worlds universe, that process doesn't just continue in one timeline, it continues in all timelines. Every possible version of the pattern exists, every possible configuration of the wave. And your subjective experience is just one thread through that vast tapestry, one path through the garden of forking paths. From this perspective, quantum immortality isn't saying you're immortal. It's saying the process is immortal. The pattern continues, not because it's protected or special, but because that's what patterns do. They flow, they adapt, they branch, they never truly end, they just transform. And your fear of death? That's the ego. That's the illusion of being a discrete thing that can be destroyed. But you're not a thing. You're a process, and processes don't die, they just change form. The Buddha taught this 2,500 years ago. He called it anatta, no self. The idea that there's no permanent, unchanging self, that the feeling of being a unified, continuous I is an illusion, a story the mind tells itself. And when you realize this, when you truly see that there's no solid self to protect, fear dissolves. Because what is there to lose? Quantum immortality, from this perspective, isn't a prison, it's a liberation. It's the universe showing you that you were never trapped in a single timeline to begin with. You're not a prisoner of fate. You're not a helpless victim of probability. You're the process itself. You're the wave, and the ocean is infinite. This doesn't mean death doesn't hurt. It doesn't mean you won't grieve when loved ones disappear from your timeline. It doesn't mean suffering isn't real. Pain is real. Loss is real. These are part of the process too. But it means you can let go of the fear, the deep existential terror of non-existence, because you're not trying to preserve a thing. You're just flowing like water, like energy, like the wave rolling toward shore. And when the wave crashes, when the pattern dissolves, what's left? The ocean. And the ocean was always there. You were never separate from it. You just forgot. You identified with the wave, with the form, with the pattern, and you feared losing it, but you can't lose what you never were, and you can't keep what was never solid to begin with. This is quantum Zen, the marriage of cutting-edge physics and ancient wisdom. And maybe it's the answer to the horror of quantum immortality, not to deny it, not to fear it, but to see through it. To see that there's no you to be immortal. There's just the process, and the process continues because that's its nature. And you reading these words, you are the process becoming aware of itself. You are the universe observing itself. You are the wave realizing its water. And that realization, that moment of clarity, is all you need. Because in the end, quantum immortality doesn't matter, whether it's true or false, whether you live forever or die tomorrow. What matters is this moment, this breath, this experience of being conscious, of being aware. And that no matter what the equations say, no matter how many timelines split or collapse, that is always here, always now, always enough. Let's be honest. We don't know, despite everything I've told you, despite all the theories and equations and thought experiments. We don't know what happens when you die. We don't know if quantum immortality is real. We don't know if many worlds is correct. We don't know what consciousness is or how it relates to physical states. We don't know if there's an afterlife or if death is the end. We don't know if you'll become a Boltzmann brain or if you'll simply cease to exist. All we have are models, maps, stories, attempts to make sense of the mystery. And maybe that's okay. Maybe uncertainty is not a bug. Maybe it's a feature. Because if we knew for certain what happens after death, would life mean anything? If you knew you were immortal, would you live differently? If you knew death was final, would you appreciate this moment more? The uncertainty is what gives life its weight, its urgency, its beauty. You don't know how much time you have. You don't know if this is your only chance or if you have infinite chances. And that not knowing forces you to be present, to pay attention, to care. Quantum immortality is a thought experiment, a logical conclusion drawn from a particular interpretation of quantum mechanics. But it's not a fact, it's not proven. And even if it's mathematically consistent, that doesn't mean it corresponds to reality. Math is a language, and sometimes the sentences we write in that language are poetry, not prose, metaphor, not literal truth. So what do you do with this information? How do you live your life knowing that you might be trapped in an endless consciousness or that you might wink out of existence at any moment? I'll tell you what the physicists do, the ones who think about this seriously, who grapple with these questions not as entertainment, but as existential riddles. They live as if death is real and final, because whether or not it is, acting like it is makes you appreciate life more, makes you treat each moment as precious, makes you connect with others, makes you leave a mark, makes you matter. And if quantum immortality is true, if you do keep branching into survival timelines forever, well, then you'll have eternity to figure that out. But for now, for this timeline, for this moment, act like it's the only one you've got. Because from your subjective perspective, it is. This is the wisdom hidden in the horror. Quantum immortality, if it's true, means you can't die from your own perspective. But that doesn't mean this timeline, this version of you, this specific configuration of consciousness is guaranteed another day. This version of you, the one experiencing this moment right now, is unique. And whether it continues or not is genuinely uncertain. So love the people around you. Do the work that matters. Create something beautiful. Be kind, be curious, be brave. Not because you'll live forever, but because this moment, this precious, fleeting, irreplaceable moment is all you can ever truly have. And if you wake up tomorrow in another timeline, another branch, another version of yourself, well, that version will face the same choice, the same uncertainty, the same precious now. And that's the strange comfort of quantum immortality. It doesn't rob life of meaning, it multiplies it. Every choice matters because every choice creates a new branch, a new you, a new future. And somewhere in the vast tree of possibility, every version of you gets to exist, gets to make their choices, gets to live their truth. You're not one person living one life. You're infinite persons living infinite lives. And this one, the one you're living right now, is just as real and just as important as all the others. So don't waste it worrying about whether you're immortal. You're not. At least this version of you isn't. This version will end someday, somehow. And when it does, maybe there will be another version in another timeline, and maybe there won't. But either way, you, the you experiencing this moment, has work to do, has love to give, has beauty to create, has truth to discover, and the clock is ticking or branching, or both. You've made it to the end. And if you're still listening, still awake, still conscious, then congratulations, you survived, at least in this timeline. But before you close your eyes and drift into sleep, before you let go of consciousness for the night and trust that you'll return in the morning, I want to leave you with one final thought. It's not a theory, not an equation, not a prediction, just a question. When you wake up tomorrow, how will you know you're the same person who fell asleep tonight? How will you know this is the same timeline, the same universe, the same reality? Your memories will tell you it is. Your body will feel familiar. The room will look the same. But memories can be false. Bodies can be copies. And reality, as we've learned, is far more fluid than it appears. So here's the question. If you can't prove you're the same person, if you can't prove this is the same timeline, does it matter? Maybe the continuity you feel, the sense of being a persistent self moving through time, is itself the greatest illusion. Maybe you die every night, every moment, every instant, and what wakes up is something new, something fresh, something that inherits your memories but isn't you. Or maybe you're the same person you've always been, threading through an infinite maze of branching possibilities, always choosing life, always choosing consciousness, always choosing to wake up one more time. You'll never know for certain, and that's okay, because the question isn't whether you're immortal. The question is, what are you going to do with the time you have? And the answer, the only answer that matters, is live. Live like this is your only life, because from your subjective perspective, it is. Live like death is real, because for this version of you, it might be. Live like every moment counts, because whether you have one life or infinite lives, this moment, this precious, irreplaceable moment, only happens once. So when you wake up tomorrow, whenever tomorrow comes, don't ask if you're the same person. Don't wonder if you jump timelines. Don't question whether quantum immortality saved you one more time. Just open your eyes, take a breath, and be grateful for the mystery, the uncertainty, the not knowing. Because that's the space where life happens. That's where meaning lives. That's where you, whoever and whatever you are, get to exist. Even if it's only for a moment, even if it's only now, even if it's only this.